In this video, we're going to work through problems 4 through 6 of section 13.6. And these are an interesting variations. We're basically going to be asked to do a partial expansion or find a specific term of an expansion. So before, we've been working all the way from beginning to end. In the next couple examples, we'll have a kind of a truncated version. So the first problem says, find the first three terms of 2x plus y squared to the 10th. So, nice thing, we can start with knowing our coefficient family is going to run 10. And since we only need the first three terms, I know that I'm going to need a 10, 0. I'm going to have a 10, 1 and a 10, 2, and I'll start building them in a couple seconds. What's the clue as we build an individual term? Remember, it's always the value that the exponent of b matches the bottom line in the combination family value. In that case, it'd be 0. So it's b to the 0, and since a is 2x, we're going to have 2x to the 10th. Our next term, hey, now we just start writing out the coefficient family and the combination family of 10, 1, y squared to the first power, so it'll just be y squared, but I'll put it to the first just so we can see it. There's a 1 there. And 2x goes to the 9th power. Finally, what happens? We're going to have our last term, because we're only asked for 3, is a 10, 2, 2x to the 8th, y squared squared. So I'm going to do a little bit of work off to the side just to save myself a little bit of real estate. 2 to the 10th is 1024. So I'll just mark this up here. I'm going to have 1024 x to the 10th as my first term. A 10, 1 is 10. 2 to the 9th power is 5,120. So I'm going to have 5,120 x to the 9th. So 512, excuse me, x to the 9th. 512 x to the 9th. Sorry about my handwriting there. Again, 512 x to the 9th. That's going to be multiplied by 10. And then y squared to the first. And my last term is a 10, 2. If I go to the calculator, I'm going to get 45. 2x, that thing raised to the 8th. Well, 2 to the 8th is 256. So I'm going to have, excuse me, I'll remove a couple pieces of paper. 256 x to the 8th, and y squared squared becomes y to the 4th. Now, if I work to simplify that, my first term is good. It's 1,024 x to the 10th. I need to multiply 10 by 512, and what I'll come up with is plus 5,120 x to the 9th, y squared. And then I got to do 45 times 256. That turns out to be 11,520 x to the 8th, y to the 4th. And that problem's done. All right. Now, we have a nice formula for the kth term of the binomial expansion. It's in the textbook for that matter as well. And it's a very nice structured formula, but it does get maybe a little bit more complicated when we need. I'm going to talk about the way we go ahead and build our coefficient family, our combination family, when we work a binomial expansion, and we might see a way that's going to be a little bit more intuitive and straightforward. So our next problem says it wants the fourth term in the expansion of x plus y to the 15th. So first thing I know is my first term would look like this in terms of its combination family member, and then I'd have a couple other pieces. My second term is going to have a 15, 1. Third term, 15, 2, and the next term is going to be a 15, 3. And by the way, doesn't that match up with the fourth term? Find out the answer is, it sure does. That helps me a great deal because knowing that's the term I need, that's what the fourth is, just go ahead and give myself a little bit of real estate now, I can build the exact members that belong to the fourth term. So remember, our binomial coefficient, since the fourth term must be 3, so the value of b must be raised to the power of 3, and a to the power of, remember, the power's got to add up to 15. A must be raised to the power of 12. So my term is simply 15, 3, x to the 12th, y to the 3rd. And if I do some quick work, calculator on, 15, math, PRB, choose my combination option, put in a 3. So I got a 15, 3. I come up with 455 x to the 12th y cubed. So a very straightforward way to work. Okay, let's do it one more time. More complicated structure. We had a nice x plus y, pretty basic. Now we have something a little bit tougher. We have 3x minus 2y to the 12th. Let's take a look at this, see what happens. Well, following the same logic, if I went 12, 0 and kept counting, when I get to my 9th member of the combination family associated with 12, looks like a 12, 8. Again, 12, 0, 12, 1, 12, so on and so forth. My 9th thing that I would say would be a 12, 8. So I know already my combination coefficient that needs to go here. It makes it very easy. In this problem, A is 3x, B is negative 2y. Let's go ahead and build. B must go to the 8th power, negative 2y to the 8th. 3x must go to the, 4 plus 8. 4th power, 4 plus 8 equals 12. So I'm in pretty good stead here. I have my pieces, do a little bit of work. A 12, 8, combination-wise, becomes 495. 3x, that whole thing raised to the 4th, well, 3 times 3 times 3 times 3 is 81. So I'm going to have 81 x to the 4th. Notice I'm just kind of using parentheses here so I can see the numbers as they fly along. Next, negative 2y raised to the 8th. Well, negative 2 raised to the 8th turns out to become a positive number. Remember, negative number raised to an even power always produces a positive number. Negative 2 to the 8th gives me 256. I'm going to have y to the 8th. So the last step for me is just to multiply. I know I'm going to have x to the 4th, y to the 8th, and the last piece for me to do is multiply 495 times 81 times 256. I'm going to get a pretty big number. It's got 8 characters, so it's in the 10 million. 10,264,320. 10,264,320, x to the 4th, y to the 8th. And there you have it.